All right, so we continue the topic of big picture of data analysis topics that you have learned up to this point. So what we're going to focus on today, we're going to bring more details. In addition to that, what we're going to do is making sure we use an example on jump to practice everything. Okay, so what do we do before we go for relations or differences analysis? So we know that these two types of analysis exist, and they have different analysis related to those. But the actual question is that what do we do before this, and how do we recognize we have to do a relations or differences analysis, right? So for that would be before this part. Before this part, what we do, first you receive your data, right? First thing is you receive your data. You're going to recognize what kind of data you have. So determine type of data. And when you determine type of data, what do we mean? What types of data or variables do we have? We have numerical or quantitative, and we have qualitative or categorical, right? Quantitative or qualitative. You can also say numerical and categorical. Make sense? So qualitative. Okay, so categorical. Perfect. So then, what do we do with those? You also need to recognize or determine response variable, response, and explanatory, or in other words, IV and DV. Which variables IV, which variables DV. You also need to determine type of data. Determine response explanatory variable, determine type of data. Why? Because these are going to help you to know, should you run a relation or differences? Should you run simple regression model, multiple regression, chi-square, Cramer's V, or ANOVA, or t-test, or one-way or two ways ANOVA, right? If you don't know what kind of variable you're dealing with, it's not easy to determine that very second part. Right, then what's next? If you remember at the beginning of semester, when I was explaining about categorical and numerical, or continuous and categorical data, I told you if you have numerical, and here we address numerical data as, which is equivalent to continuous, okay, numerical continuous. What we do, the first analysis we run is a descriptive analysis. What is descriptive analysis? So for numbers, for numerical values, we're going to calculate mean, median, right? Mode, mean, median, mode, standard deviation, variance. We're going to calculate skewness, kurtosis. We're going to calculate, also we can look at the normality of data, using Shapiro-Wilk or using quantile plot. And then what else do we check? We can also check a few other things. Check. Let me see what else is left. Normality, and then we can check the histogram. We can check histogram, and we can check, of course, quantile plot or QQ plot, and then we can check box plot, box plot. And what do all these are telling us? Why are we looking at these values? The reason is we want to recognize what kind of data we're dealing with, especially if you have normal data. With normal data, we have more reliable analysis in the future. So normality is actually very important to us, okay? However, if initial data are not normal, there are many ways we can work on those. And actually many assumptions that we have on regression analysis, they actually don't depend on the normality of the data itself. They actually have something to do with normality of residuals. But in many different cases, I can say in maybe 90% of cases, when your data are not normally distributed, your residuals probably won't be normal. And we can't really confirm that, but that's something that normally happens. Okay, box plot. So, and that's pretty much it. Of course, we can add many other descriptive statistics here. What else? So that's if you have numerical or continuous data. Let's make it like a dark blue. And you have also categorical or qualitative data. Categorical. Or groups. Group data, right? If you have group data, what kind of analysis can be run? This is not about relation or difference. This is not about effect. This is about one variable itself, not the relations, not the effect. This is just about that specific variable itself. So you make sure you put all numerical data together. So separate them in your mind. Numerical data are separate, categorical data separate, okay? When they are categorical variables, what kind of analysis we run? We do pie chart. Before pie chart, what do we have? We have frequency table. And again, this is for one variable, not multiple. Frequency table. Perfect, Pareto chart, yes. Pareto chart. What else do we have? We have pie chart. Pie chart. Someone said mosaic plot. So mosaic plot is for relation. Go down here. If you remember here, right? This is when you have two categorical variables. Again, what I'm explaining up here right now is just one variable. for the variable themselves, not any effect, okay? We can step a pie chart. Is there anything else I can add here? Any idea? Not much, right? Okay, so how do we recognize which analysis to run? It really depends. Analysis to run. Which analysis to run? Depends, right? Depends on IV and DV. How? It's all down here. If you have one IV, one DV, both continuous, these are the analysis. If you have, which is scatter plot correlation, R-square, simple regression model, and conditions. If you have multiple continuous IVs and a continuous DV, scatter plot, matrix, correlation matrix, R-square multiple regression model, and checking conditions. If both of them, IV and DV, are both categorical, contingency table, Mosaic plot, chi-square, p-value, and Cramer's, right? There's one more analysis I've missed here, and that's analysis for the logistic regression. That's what I'm adding today. So there's a question, if it's only one variable, do we still care about IVDV? No. When it's one variable, it doesn't really matter they're DV or IV. However, when you want to go down here to complete the rest of the analysis, you already need to know, that which one is IV, which one is DV. Here in analysis of association or difference, that's where IV and DV are important. At the beginning, you just need to explain this data has this much average, this much skewness, is it normal or not? What's the histogram look like? What the box plot looks like, and analysis like that. Good. Yeah, so I was saying that there's one analysis I missed, and the analysis I want to introduce you is actually, it can be very complicated, but I simplify it to the very simple example at this point, okay? So we're not going through it. I just want to make sure you have heard about it and you know what it is. So what that is actually, it's called logistic regression. And what is logistic regression? Logistic regression is when you have a continuous IV, continuous IV affecting, or maybe we should say association or relation of a continuous IV on a categorical DV. So this time it's a categorical DV, right? We'll see if there's such relation exists. What test do we use? Logistic regression. Logistic regression. Okay. Question? Any question? Ask if you have a question. Okay. So logistic regression. So DV is not only categorical, it's not just groups, it's a specific type of groups that we call them categorical, and at the same time we say it's logic, categorical logic DV. What do we mean by logic DV? Logic means it can accept two, it can only accept two values. true or false, yes or no, pass or fail, good or bad, completed or incompleted, right? So if that's the case, we can use logistic regression. And what are we looking at? Again, logistic regression is an analysis with a lot of complications. So we're just simplifying. We just want to look at the p-value and making sure that p-value is below 0.05. And if that happens, we say the relation, the association exists and it's significant. Significant relation. Okay. So let's see. So that's one. And then we have analysis for differences, and I've said all of those in the past session. So the next we want to practice the logistic regression before we go forward. So if you go to your canvas, if you open canvas, I'll give you time to log on and go to canvas. If you go to canvas, under your class, which is DS6, under files, and should be, let me check, should be under folder data. You see logistic regression example. Can you see logistic regression example? It's right there, I can see it. So that's your class. Go to files, folder data right there, up there. And that's 1, 2, 3, 4, 5, 6. The seventh data is logistic regression data. You just open it. And here, download. And it just opens down here. Trying to open it. Hope it works. Yeah, it works. So cool. So look at this data. I'm going to explain what this data represents. Data represents, so imagine that you go to an interview, and in that interview, they give you a task, and if you complete the task, they say, okay, this person could in a certain time complete the task during the interview, and there are people who they can't complete the task, right? Some do, some don't. And another question they ask you is how many years of experience you have. So they want to see and find out, is it a jump file? Yes, it's a jump file. The jump file, you have jump on your computers, right? So go to Canvas, download it. It's going to open using jump. So yeah, so they ask you how many years of experience you have, and they look at your results during the interview, and they see, okay, this person has completed or not completed the task. So we want to see, we want to explore and find out if years of experience has anything to do with completing the task on the interview session. That if that relation actually exists, that is confirming that our task is reasonable. It's something that it's good, right? That's saying we have to hire. That's also saying we have to hire more experienced people. Okay. Or if you hire someone, you need to give them opportunity to gain experience, and be good at it. So how do I run the analysis for logistic regression? Simple. What is logistic regression? Logistic regression is when you have relation between a continuous IV to a categorical logic DV. So my DV is completed task. And is it logic? Yes. It just has yes or no. So do I have a continuous IV? Yes. How many IV DV do we have? We have one IV, one DV, one-on-one relation. So click here, years of experience is IV, X factor, completed task DV, logic variable, go to Y response. Click OK. Click OK. Gives you a lot of information. It's actually a regression analysis, but I want to make it easy for you. You don't want to go through all those probability and likelihood thing. I just want to show you where to look at and see that this relation exists or it doesn't exist. So I look at down here, the values of the model, p-values below 0.05. So that's telling me that there is a significant association here. The more years of experience you have, the higher the likelihood of completing the task. That's what we expect to see here. Okay, the more experience you have, right, there should be a higher. Okay, so one more time. Yes, I can do it one more time. So you have the data, right? Give me 1 second to see what the question is. So the intercept and slope, yes, because it's a linear, simple linear regression analysis, right? So yes, that's has to be below 0.05, both of them. Again, I'm not, I'm just explaining it in an easy way. The analysis of regression actually requires more checking more most of those conditions you learned for simple regression model. And it's actually more complex to interpret. So I simplified the concept of logistic regression for you to just to understand, get the idea of what a logistic regression is. So what is logistic regression? Regression, when you have a continuous variable affecting a logic or a categorical DV, and you want to see if this relation exists, you look at the p-value below 0.05, yes, there's a significant relation there, okay? So one more time, go to analyze, because I have one IV, one DV. So I go to analyze fit y by x, and I select years of experience. IV is continuous, completed task is categorical, DV. And if you look here, look upright, it shows logistic. If I take this out, you have bivariate because it's waiting for a continuous variable to go in, but I do a categorical response that changes to logistic. Okay, all I have to do is to click OK, see the result, look at the p-value. Can we interpret the rest? Yes, but for this class, it's just too much. For those who study economics, econometric, we normally teach those stuff. Okay. All right, so that was logistic regression in a very simple way. And let me close this. Is there any question for logistic regression? Perfect, no questions. So let's just continue. So now it's time to open. Jump, and this time we're opening company's data. So click on company's data. That's my company's data. And what I need here is I want to do a complete analysis here. So when I see this data, what do I think first? What is the first step? It's the first step of my analysis. Go up here, determine response explanatory variable, right? Normally questions will tell you, but the question does not mention which one is DV. Of course, what can help the company to survive? Which of these factors can help a company to survive and actually stay alive? Which one? Without which one your company is dead? Profit. Profit. Yes, Daniel. Yes, Diego. Yes, profit. Without profit, a company is dead, right? So they'll be gone. So profit is my DV. Look, it's not difficult. The question should not mention it. You as a data analyst, you're supposed to, when you see the data, you're supposed to know what to look for. What am I looking for IVDV? What is my DV profit? What's the IV? Everything else is IV. Everything else is IV, right? So now the next step is, I want to know, I know which one is IV, which one is DV, but I need to determine the type of data. What type of data I'm dealing with? Is the DV categorical? No, the DV is continuous. It's numerical. And especially it's continuous because it has decimals, right? So how about IV? Sales, number of employee, profit, asset, person profit per sales. These are all continuous or numerical. So when I'm looking at analysis, if I want to analyze profit being affected by sales, number of employee, profit, asset, and person profit per sale, these 5, what analysis do I run? Multiple regression, because I have multiple IVs and one continuous DV, multiple continuous IVs, one continuous DV. Which analysis is that? Multiple regression, as simple as that. So simple. And then you know the rest, right? You start putting all those X's down there. So let me do it and show you. So you're going to go to analyze. For regression model, I will go to fit model. So how about categorical variables? The first two are qualitative or categorical. Qualitative or categorical. None of them are DV, so I'm not dealing with a chi-square test because I don't have a categorical DV. Another test with categorical DV is logistic regression. So logistic regression or chi-square, they don't mean anything here because we don't have a categorical DV, all right? So now, what's next? Look at that note you wrote there. What's next? We have to analyze each variable. For numerical variables, descriptive statistics. So what I do, go to analyze distribution, select continuous ones, go to Y column. I'm only analyzing the distribution of my continuous variables. Click OK. Because there are many analyses here. Okay, so you can see different information. And down here you have the information too. You want to add any information, red triangle, customize, check whatever you want to add. And down here you can simply determine the confidence level. This is 95%, a 5% error. You want to change it, you can change it if it's 99 or whatever else. What else do we have? We have a histogram, box plot. We can also add normal quantile plot down here. That's right there. It's not normal. Okay. And report mean, median, mode, standard deviation, variance, upper and lower 95%, and all of those stuff. Okay, so that's your step 4. First step for analyzing continuous data. How about categorical data? For categorical data, I go to analyze. There are a few ways to do this. I can go to Tabulate and create a frequency table, or I can go to Graph and create, go to Legacy, Chart. I can create a bar chart, pie chart here. All I have to do is to select, drag and drop into categorical X. This is going to give me a bar chart down left, you can see it. Okay, so and vertical, I can change those to pie chart, line chart, needle chart, point chart. So that's all I can do. You can just create a bar chart. If you want more information added to here, you just go here, vision position, and then you can add title. You can also do a lot of things here. Or you can also right click here and add more information like labels, right? You can change colors, you can do a lot of things here. All right. Make sense? So that's the first step of analyzing any data. When you receive data at the beginning from your manager, that's how you start. You separate continuous and categorical IVs, DVs. Make sure you know which one is IV, which one is DV, and start thinking about analysis. So after analyzing the first part, it's not working. Okay. After completing the first part of analysis, then we go for more complex analysis, which is fit model. So fit model is when you have multiple IVs and one continuous DV. DV continuous is profit, goes here. The rest of them, hold control, select them, go to click on add. You can add it all here. Make sure you minimize report, and that's it. Click run. And you need the rest, right? You need to remove those non-significant ones in here. Profit per employee also, remove it. When my all p-values are below 0.05, I know that this system is what I'm actually looking for. Here's my scatter plot matrix, analyze, multivariate methods, multivariate, and I select profits first because DV, and then the rest. I go down here, click OK. That gives you a scatter plot matrix and correlation matrix right there. All the information and correlations you want, they're all available under the first column, which is your answers for your DV. Okay. Yes, I can. So analyze. That's for correlation matrix and also scatter plot matrix. So analyze multivariate methods, multivariate, and simply select DV first. Select DV first, then select sales, and the rest. Note these are all continuous variables, no categorical at this point for answers. That's your scatter plot matrix. What other analysis do we run here? Mahal-Avis test, red triangle, outlier analysis. You're welcome, Shane. Outlier analysis, Mahal test. Few of these are outside the range. Upper control limit is 3.35. These are too high. You can eliminate them. And after that, we can eliminate these two and see what happens without data sets. Okay, so that was good. Okay, what else can we do? We can run those one-on-one. So one-on-one, we have simple regression model. We already covered under multiple regression. So you don't need to run a simple regression model. We have categorical IVs, right? The categorical ones are 2. So let's say that size of a company is affected by type. So let's see how significant that is. They're both categorical. So I go to analyze fit y by x because it's one-on-one analysis. Type and size. If you look back to your notes, you can see that both categorical IV and DV. What does that indicate? You have to use a chi-square test. So size being affected by type of company. They're both categorical. They're both categorical. All I need to do is to click OK. Let's see the results. We have Mosaic plot. We have contingency table. And how many times have we gone over these? So we have Pearson chi-square test. We have a p-value associated to it. And from there, you can calculate the Cramer's V. What else can we do? Now it's time for group analysis. Group analysis, chapter 25 and 26. We go to Tabulate. We go to Tabulate. Tabulate, I'm going to see some information, get some information from my categorical variable, okay? So type. We drag and drop type of company down here. It's actually type inside. It's actually separating them using frequencies. Now I don't want frequencies. I want to see if for different types and size of company, we have different amount of sales or profit or number of employees. So what should I do? I should add that variable, for example, number of employees or profit or sale. Number of employees. Number of employees goes on N. Number of employees goes on N, right? That shows the sum. This is what's the sum of number of employees in computer companies versus pharmaceutical companies. What's the sum of number of employees in big companies versus medium versus small? Does that make sense? Okay, so you don't want sum, you want average. You just click on average, drag and drop it onto sum. That changes sum to average. If you want both of them at the same time, drag and drop mean into sum, next to sum. But when it's a small vertical bar, it's a small vertical bar next to sum, let it go. It creates the same information, but instead of sum, you have average or mean. It's cool, right? That's cool. So Tabulate is very cool to work with. As for number of employees, can I do for other things like profit? Yes, why not? Profit, bring it next to a number of employees. It's a small vertical line, you have profit. Same information, same information. Can I do it for the rest? Let's try. So I have never tried this before to put 3 of them at the same time. Let's see. Yeah, it works. Perfect. Perfectly works. It's nice. Okay, so you have all this information. But why do we run a tabulate? Why do we run a tabulate analysis? The main reason is we want to see visually, we want to see if there is a significant difference between groups. Do you see a significant difference between the groups of big, medium, small size companies regarding number of employees? I personally see, yes. Big companies have an average 98, in fact, 98,618 employees. Medium-sized companies, they have an average 28,000 number of employees, and small companies has 8,700. So are they significantly different? We cannot say visually. You have to take a test. What test? Depends on how many groups you have. Here you have 2 groups. For 2 groups, what analysis? And they are independent, so that's independent t-test. For 3 groups, anytime you have more than 2 groups, doesn't matter how many. For more than 2 groups, you do ANOVA test. Let's run those tests. Very simple. You just go to Analyze. So before you go here and select something, the question is, what's the IV, what's the DV? When you want to see if there is a significant difference, so let me write this down here just to make sure you're all aware of it. So for differences, this is what many students get confused and they don't understand it. When it comes to exams, they're 100% confused. They don't know what to write. So look, when you have a group variable like size, right? Size. So I want to see if size of a company is having any kind of effect on, that's the question. Does size of company affect, for example, profit? So in what situation this effect exists? Such effect exists if there is a significant difference among groups of size of company. Does that make sense? So, of course, regarding profit, because profit was DV, right? I have to write the DV here. So this effect from size to profit exists if we have an existing difference among the groups in size. Okay, that's how we look at it. That's where this turns into a hypothesis test of differences. So let's just do it. So before I go forward, the point here was, do you recognize how many IVs and DVs we have? Look, IV is size, DV is profit. How many? One. One IV, one DV. That tells me use fit Y. That tells me use fit Y by X. And fit Y by X, so let me see. Profit goes here, and size of company goes here. So size of company is independent variable, profit is dependent variable. Click OK. Groups are separated. Visually, we can probably say there is some kind of difference because these are not in the same level in average. So what test should I run? You have more than 2 groups. What test should you run? ANOVA test. So click on red triangle, means ANOVA. Where do I look at? Analysis of variance test, p-value. P-value, if it's below 0.05, reject catch, oh, there's a significant difference between or among these groups. And because of that significant difference regarding profit, we can say such effect exists. So there's a significant effect from size of a company to profit. The size of a company can help a company get more profit. Okay, that's what we can say here.
Where did you go for that again, Professor?
One more time. So the point is, and you need to recognize what analysis you're running. You're running analysis for checking if there is a relation or association between the size is affecting profit. Size affecting profit. Is that happening? How do I know it's happening? I need to make sure that there is a significant difference between the groups of size. So since I have one IV, one DV, I go to fit Y by X. I go to fit Y by X, and I chose profit as DV and size as IV. Size has more than 2 groups, it has 3 groups. So I expect to use ANOVA test. I run, shows the differences, one way. ANOVA is a test that's required here. It's right there. Just click, look at analysis of variance table, p-value to be below 0.05. So we can say, reject HO, there is a significant difference between small, medium, big companies in profit, in average profit. And however, here with this, we can also say that size of a company has effect on, size of a company has effect on the profits. You can see that it's changing, right? The bigger the company, the larger the profits. Okay, good. That was a good topic to talk about. So what else do we have? Another analysis. Let's run another analysis. So that was ANOVA. How about t-test? Again, you have one IV, one DV, but for t-test, you need 2 groups. Type has 2 groups. 2 groups, profit up there. That's it, right? Click OK. You have 2 separate independent groups. You go to t-test, red triangle t-test. That gives you what you need. So this is 2-tailed test. Look at the p-value with the absolute of t. Absolute of t is not below 0.05. It's up here, the black color. It's not below 0.05. As a result, we can say, do not reject HO. There is no significant difference here. There's no significant difference, or there's no effect. Type of company doesn't have effect on profit, statistically. Okay? What else can we run? Does size of a company be affected by type of a company? Again, fit Y by X, fit Y by X, type. I think we have done this, right? Type, size. That's a chi-square test, categorical to categorical. And we look at the p-value here. Yes, there's a significant relation here, association between these two. Mosaic plot confirms that. You can see, by changing the categories, the size of squares are changing, rectangles are changing. All right, so that was pretty much what we expect on this topic. But what do we do at the end? What do we do at the end? So let's say we have completed all these analysis, and we already know which variables have significant effect. What would they do with it? At the end of the day, assume. So we are assuming, okay? It's not actual reality. So assume that size, number of employees, and percent profit per sale have significant effect on profit. If that's happening, how do I show this as a finalized model? I show it this way. I go here, I put insert. I'm going to graph some small shapes here, okay? Shapes. And I want some circles. I'm going to write inside this. Let me see if it's possible to write down. Yes. So this is representing profit. So profit is being influenced by, I don't want to redo this, I just copy it and just paste it. Okay, so there are 3 factors affecting profit here. One is number of employees. One is percent profit per se. And last one is size of the company. These are having significant effective profit. How do I show it? I insert again shapes, and I use one of these directions. So arrows. So I do one arrow, and then need 3 of it. And add this to my chart, to this model. That's a model. So we call it a model, right? And if you had enough patience, you can add the formula for regression model here, including p-value r². And for size, you can put the ANOVA, and then write the p-value next to it. So this is the finalized model. When you go for a presentation for your top managers, they don't expect them to sit and look at all of these numbers. They're not interested in these numbers. They are not interested in those charts. They're not interested in statistics, okay? You are the data analyst. You are the one who will do all this work to come down to this point and tell them, let's say profit per se, percent profit per se has a higher effect. So how do I show it to my manager? I don't show it with numbers. I make it like bold, and I tell them this is representing, or maybe I use a different color and say that this color represents how strong this relation is. Okay, that's what a top manager wants to see. They want to see how they can increase their profit. What factors affect profit to increase? Number of employees. So they need to hire more people so they have more sales, and from there they have more profit. And of course, more employees creates less stress on current employees, probably. Of course, this can be more complicated, okay? But we're just approaching this as a very simple approach, right? So simple way. So percent profit per sale, higher effect. Less effect from number of employees, and there is an effect from size. Size, remember that is DV. It's a categorical IV. So that's what we call it, finalized model. Okay? That's what we call it, the finalized model. So you are required to know how to graph this. Look, everything you have learned up to this point is done to make sure this is a reliable model. If you have this reliable model and you make sure that the model meet all the conditions like residuals to be normal, independent. You make sure you have homoscedasticity. You make sure you have independent residuals, and so on. P-values all below 0.05, and so on. Then you can say that this model is reliable, and you can make sure if you show this model to your manager and he used this model, he can actually manage that company and make more profit. And who makes more profit, they normally appreciate you. And of course, you will have more value because your model is giving a good answer. So another thing I wanted to add is that, let's say you have done all the analysis perfectly correctly. You're an A student and you perfectly know all the details, even more than your professor. My question is, what can go wrong that this perfect model being created, pass all the assumptions, all the conditions? What can happen that this model represents a wrong? Or you can say, what can happen that this become unreliable? Anyone has any idea? So you have your data, everything is perfect. You have all p-values, you have all analysis run, and you met all the conditions. So what can happen that makes such model unreliable? I'm waiting for your comments. Perfect. Lurking variable is one of them. Remember, one of the signs of lurking variable is that you will not have those normal residuals. But still, we can have a perfect model, but with lurking variable, and that actually creates a wrong interpretation, and wrong model can lead to wrong decisions. Thank you. Ernan Cortez was a good answer. Any other opinion, comments? Is there any other way we can have this model to be unreliable? This is the topic that I talked about in the very first class we had this semester. The first topic I started with. I said something. What was that? I'm writing it here. Hopefully you low sample size. So one of the students saying, Diego is saying less samples. That's actually true. Or yes, less data, right? Less data. But when you have less data, what happens that? What's the nature of that failure? Where is that? What's happening that this data is not showing what it's supposed to? Because even less data, if it's collected correctly, it can actually show some significant relations and can be reliable. But normally when you have less data, things will go wrong because sample does not represent population. Does that always happen when you have less data? No. I told you I had a student in the past who collected all the data from her friends and from Facebook friends and here and there, and concluded in the US this is happening. But his data, actually many of those data were collected from another country or from friends who came from another country, and they didn't have much idea of what's happening in that topic. So that makes it unreliable. So data is very important, data collection. So let me add it. data collection is very important. Okay, and what do we expect from data? So the sample represents the population. That's what we expect. If that's happening and all of those tests we run is correct and meet conditions, then we can use this. We can show this graph, add it to histogram, bar charts, pie charts, and frequency tables, and show it to our managers, right? And ask our managers to use these to make a decision, how to increase profit, for example. Does that make sense? I think if you get the point here, that's the whole thing for the semester. I mean, all we did up to this point is for this, to get to this point, to get this total finalized model that we can show it to our managers without putting all those numbers around it. All right, so that's pretty much what I wanted to explain for today.